And good morning, everyone. Thank you very much for coming. Today, today I'd like to talk about the detection of protein heterogeneity by HPLC.
It's still got to be louder.
Oh, sorry.
No, it's just, yeah, it's not a mic, just louder.
And to begin with, I have to say that my English is so rather limited, so please bear with me. Thank you. So next, please. This is the outline of my presentation. Mainly, I'd like to talk about the studies on protein separation by the following four chromatographic modes: size exclusion chromatography, and reverse phase chromatography, hydrophobic interaction chromatography, and ion exchange chromatography. So next, please. So first, oh, sorry. The sources of protein heterogeneity are classified into the following three groups. The first is the post-translational modification, such as phosphorylation and dephosphorylation, glycosylation, lipidation, methylation, acetylation, and protein splicing. The second group is decomposition, such as proteolysis, deamidation, and oxidation. The last is other kind of heterogeneity, including artificial chemical modification, like PEGylation, and conformational change and aggregation by denaturation. So, monoclonal antibodies are now widely used for therapeutic treatment because they are expected to be more effective and less harmful than traditional chemotherapy. Antibody might display heterogeneity like other proteins, as I mentioned earlier, and that might undermine the therapeutic efficacy and increase the risk of toxicity. Therefore, the evaluation of the heterogeneity is essential during development, stability testing, and in the quality control of the final products. In this part, I'd like to show some examples of protein separation. The first is separation by SEC, size exclusion chromatography. This slide shows the SEC chromatogram of immunoglobulin with a variety of molecular weights. Sample and their molecular weight are shown here, there. Transferrin and number 4, transferrin and number 5, human serum albumin are not immunoglobulin, but they are the other major components of human serum. This chromatogram was obtained with TSKgel G3000 SWXL. In most cases, G3000 SWXL provides good separation for most proteins. The right figure was obtained with TSKgel G4000 SWXL. G4000 SWXL has a larger pore than G3000 SWXL. So the large protein like IgM was retained on the G4000 SWXL. Therefore, for analysis of larger protein, G4000 SWXL is more recommended. Here you find that the peak of IgM and IgA, IgA and IgG. This showed some distortion in this peak shape. That implying that these antibodies were heterogeneous due to the fact that they are polyclonal. Next, please. This picture presents the diagram of IgG structure. IgG is a large protein with a molecular weight of 150 kilodalton. So, in some application, IgG is digested into small fragments by Papain or pepsin. Papain digestion is 2 Fab fragments and 1 FC fragment. And in contrast, pepsin digestion is 1 Fab fragment, and in this case, FC region is further digested into subfragments. This slide presents a time course of digestion by pepsin and analyzed by SCC column. Before the digestion, only one peak of intact antibody was detected, and digestion proceeded. The amount of intact form decreased, and in contrast, Fab2 fragment increased. Next, please. I'd like to present another example. This slide presents the time course of the digestion by Papain. The digestion proceeded, the intact form decreased, and FC fragment and Fab fragment were increased. This slide presents the separation of antibody monomer and dimer. Here you find that the baseline separation was achieved for monomer and dimer. As we have seen, ACC mode is available for the separation of fragment or dimer. This species might induce toxic side effect, so that determination of them is essential for quality control of therapeutic antibodies. In this slide, I'd like to present 3 novel columns, especially designed for the analysis of antibody, named TSKgel SuperSW MAP HTP and TSKgel SuperSW MAP HR, TSKgel UltraSW Aggregate, and these 3 columns. Please keep in mind that these columns are prototypes and as yet unreleased. These 4 figures illustrate the separation of Papain-Digested antibodies. analyzed by the 3 noble column and conventional column TSKgel G3000 SWXL. Figure A shows that separation by super SW maps HTP. HTP means high throughput. This is a semi-micro short column with 4.6 millimeter by 15 centimeter. Then this column is packed with 4 micron particles. Using this column and dimer, monomer, and fragment, these peaks were separated at the same resolving power to the G3000 SWXL in half the analysis time. Next, figure B shows the separation by TSKgel super SW map HR. HR means high resolution. This is a standard long column with 7.8 by 30 nanometer, 30 centimeter. And the packing is the same as super SW map HTP. And this column provided higher resolution than the conventional column. Next, figure C shows the separation by UltraSW aggregate. This column is packed with a particle of the 3 micron and the pore size of 30 nanometer. It is designed for the separation of aggregate. This column has a larger molecular size, larger molecular weight exclusion limit. So, compared to the other silicons, A, B, and D. So, concerning this point, I'd like to describe more in the next slide. Here, figured on the left side illustrate the separation of antibody, including monomer and dimer. That is by UltraSW aggregate, and the right side is by G3000 SWXL, a conventional column. The lower figure is a magnified view of the chromatogram shown in the upper figure. This area is magnified here. And this red line is a calibration curve for protein, indicating the molecular weight of eluting species. Here you find that UltraSW aggregate has a wider separation windows and higher resolving power for oligomers and aggregates compared to the conventional column. I'd like to show one more example of SEC separation. This slide illustrates the separation of PEG conjugated antibodies prepared with different antibodies to PEG ratios shown here. Here you find that mono-PEGylated species and di-PEGylated species were separated from the intact antibodies shown the right figure. So next, I show the example of reverse phased separation. This slide shows the separation for antibody partially digested with papain. The left figures illustrate the SEC, side exclusion separation. Here you find that intact form and partially digested form and completely digested form were separated on the basis of molecular sizes. Each fraction of antibody fragment was collected and then applied to RPC column in the right figure, and the column named TSKgel protein C4 300. And the column is based on the 3 micron silicon gel with a butyl stationary phase and a pore size of 30 nanometer. That is designed for protein separation. The protein C4 300 is scheduled to be released in the near future. Here you find that the several peaks appeared in each chromatogram, indicating that the antibody used in this study was heterogeneous in hydrophobicity, although molecular species in each peak was not determined yet. I'd like to present another study. This slide presents the analysis of two antibodies, IgGA and IgGB. Each antibody was reduced with this thiothioethyl to dissociate into heavy chain and light chain, and then applied to RPC column. Here you see that small differences in hydrophobicity between IgGA and IgGB. In addition, two chains of IgGB were eluted as a broad peak with shoulder, indicating that IgGB was heterogeneous, containing a hydrophilic variant. Next, I'd like to show the separation of PEG-conjugated proteins by RPC column. In the left figure, PEG-conjugated Lysozyme was separated by SEC. Depending on the molecular weight of PEG shown here, or the number of PEG chains, mono-PEG and di-PEG were separated. And then each SEC fraction was applied to the RPC column in the right figure. You find that PEG-conjugated species were more strongly retained by RPC compared to the intact species. This data mean that PEGylated protein are also separated by RPC as same as SEC column. Next, I'd like to show the example of HIC. HIC is hydrophobic interaction chromatography. This slide shows the separation of deamidation variant by HIC. This study is cited from these references. Three variants of monoclonal antibody was digested with papain and separated by TSKgel butyl NPR column. This butyl NPR column is a Hick column packed with 2.5 micron non-porous particles. The antibody without deamidation, the lower chromatogram, was separated into one Fag peak and one FC peak. In contrast, antibody with deamidated residue at position of 3O or 102 were separated into two Fag peaks and one FC peak. Here you find that this butyl NPR column is able to separate variant with a single residue difference, indicating that the deamidation of a single asparagine residue was recognized by the butyl NPR column. I'd like to show another example of separation by Hick. This slide shows the separation of methionine-oxidized variants by Hick. This study is cited from this reference. Antibody was oxidized with tertiary butyl hydroperoxide, digested with papain, and then separated by TSKgel butyl NPR column. Oxidized antibody was separated into one Fag peak and three FC peaks. Another sequence analysis revealed that two methionine residues at the position of 255 and 431 were oxidized. Next, please. And next, please. Finally, I'd like to talk about IEC, ion exchange chromatography. This chart illustrates the analysis of 5 commercially available therapeutic antibodies. The separation was performed by TSKgel CM stat. This CM stat column is a weak cation exchange column packed with 7 micron non-porous particles. Here you find that all of 5 analytes were separated into the couple of peaks. Antibody E. This antibody was studied furthermore, as shown in the next slide. Most antibodies are known to be a mixture of C-terminal lysine variants. In this slide, the antibody E appeared in the previous slide was digested with carboxy peptidase B to cleave C-terminal lysine residues, and then analyzed by CM stat column. The 3 peaks observed before digestion converged into one single peak. This result indicates that C-terminal lysine variants were separated by the CM stat column. Lysine is a positively charged amino acid, so lysine variants are separated by IUC, depending on the number of lysine residues. I'd like to show another example of IUC separation. This figure illustrates the time course of isomerization of ribonuclease A under alkaline condition and analyzed by a CM-STAT column. As the isomerization proceeded, the intact form, peak number 3, decreased, and the two peaks, deamidation variants, peak 1 and peak 2, increased. Aspartic acid and isoaspartic acid were negatively charged, although asparagine is electrically neutral. Therefore, deamidation variants are eluted earlier than intact form. So here I'd like to conclude my presentation. In this seminar, we have seen that several studies on protein separation by using 4 chromatographic modes. First, I displayed the separation by size exclusion chromatography. That is applicable to the separation of antibody monomer from dimer aggregates or degradation products on the basis of molecular size. I showed the 3 novel SEC column that is designed for the antibody separation. This 3 column exhibited improved separation performance for antibodies. The second, I displayed the separation studies by reverse phase chromatography. This RPC column is packed with wide pore C4 material. This column exhibited resolving power to detect heterogeneity of antibody fragments on the basis of hydrophobicity. SEC and RPC are also applicable to the evaluation of PEGylated protein. In addition, we have seen that hydrophobic interaction chromatography and the ion exchange chromatography column packed with non-porous particles exhibited high resolution enough to distinguish a single residue difference in antibodies. I hope this presentation is useful for you. Thank you very much for your attention.